We've talked previously about what it means for there to be an altitude in a triangle. In the two pictures that you see drawn, the altitude in both of them is segment BD. It goes from one vertex across to the opposite side and it hits at a perpendicular. For the other one, you have BD that's drawn here that hits the opposite side at a perpendicular, but the perpendicular in this case can't be seen unless you take that bottom side of AC and draw that in. So to fill in the definition here, an altitude is going to hit the opposite side at a perpendicular. And today we are specifically talking about when the altitude is drawn into a right triangle and it's drawn to hit the hypotenuse. So if I was to draw a right triangle that looks like this, with the right angle at the top and the hypotenuse here, if I was drawing in that particular altitude that's drawn to the hypotenuse, I would be drawing in this altitude. When that altitude is drawn in, there's technically three triangles that are formed. There's the big triangle, the whole entire one, the little left one, and the little right one. We need to consider two different cases when we're talking about the rules for the altitude being drawn into the right triangle. Case one is when we're dealing with the altitude. So when the altitude in our picture is being referenced. For this particular case, our altitude is CD. And in this case, I want to go through and draw the three separate triangles. So you can see that I have this yellow triangle that's the left one. And with that yellow triangle, I'm going to take that and I'm going to draw it over here. And I'm going to draw it in such a way that the right angle is here at D. Here's side A, here's side C, vertex A and vertex C. CD is X and AD is 7. So this triangle I'm going to take and redraw over here. And then I'm going to do the same thing with the pink triangle. The only thing is that with the pink triangle, when I go through and do this, I have to make sure that I'm drawing it facing the same direction so I can kind of compare things. So this pink triangle, in order to be facing the same direction as this one, is going to have to be picked up and turned this way so that I have the right angle over here at vertex D. Vertex C is here, and I know that this is where the CD has to go because that's the shorter side, comparing the two legs. And then vertex B is going to be up here, right angle in the lower left corner. For this particular case, I know that for CD, that is where the X is. And in this picture, I also know the length of BD from the given, which is 12. My third triangle that I'm going to go through and compare is the big blue triangle, and I want to draw it the same way. So I want to draw it in such a way that the right angle is here, which we know is at C. The shorter side is here, so if I compare my two legs, CA and CB, I want to have CA here and CB here. So to take the blue triangle and transform it to face the same way, I have to do two things. I have to take that blue triangle and flip it over and then turn it and make it land over here. So now I have my three triangles that are similar to each other, all facing the same way. The only thing that I need to take a look at here is the length of any of the sides of the blue one. And you can see that in the big blue triangle, the only length we know is that AB is 19. We don't know anything about these two other sides. It's not the altitude that we're looking for, and it's not one of the two legs of the big blue right triangle. So as I'm looking at this, I can see that the two triangles that I want to work with are going to be the yellow one and the pink one because they're the only two triangles that I know information about two of the sides on, and I'm able to set up a proportion. When I set up the proportion, it's the longer leg over the shorter leg, X over 7, equals the longer leg over the shorter leg, 12 over X. And that would be the proportion I would go through and use to solve for that altitude X. The blue triangle is not going to be used because in this case we are not able to set up a proportion because we don't know the shorter leg, I'm sorry, the longer leg or the shorter leg, so it's not going to help us. If I go through and I do the same thing with case number 2, and we're dealing with one of the legs of the triangle, you can see that they've got this side here labeled as the X. So no longer are we dealing with the X that was on the altitude. So I'm going to go back and put my little triangle pieces back in place here, so we can kind of do the same thing here that we just did for the first case. So in here, if I go through and I pull these triangles apart, I want to do the same thing again. I've got the big blue triangle that represents the whole entire triangle. So I'm going to pick that up, I'm going to flip it over, and I'm going to rotate it and translate it and get it to sit over here. So when I do that, my big blue triangle is going to be sitting here. It has C as its right angle, it has CB as its long leg, CA as its short leg, and here's where that's going to sit. So this is the big blue triangle. In the big blue triangle for this particular proportion, I do know side CA is X, and I do know that AB in this case is 12, so I want to label them on there. I'm going to take the yellow and the pink triangles and have them facing the same direction as this one. So when I go through and do that, the pink triangle just needs to get turned and set here. So this is B, D, C for that triangle. So this is the pink one. And in this particular case with that pink triangle, here's the right angle. We know that BD is 7, and we don't have any other information that we know in our pink triangle. And then I'm going to do the same thing with the yellow one. I'm going to take it and move it over here, so it's facing the same direction. And when I go through and draw this in for my yellow triangle, here's vertex C, vertex D, vertex A. In this particular case, here's my right angle. And if I'm going back now in this yellow triangle and I'm labeling the information that I know that AD is 5, and I know that CA is X. I don't know CD. So if I'm comparing my 3 triangles, the yellow one, the pink one, and the blue one, I'm going to pick to work with the yellow one and the blue one because those are the 2 that I have 2 sets of corresponding sides lined up on. I have hypotenuse over short leg equals hypotenuse over short leg, and that would be the proportion that I would go through and set up. So when you're going through and you're solving these problems, you want to make sure you're drawing the appropriate triangles. It might be the case that you want to go through and draw all 3 and figure out which of the 2 you're using and which of the 2 you're not. So over here for the second case, we did not use the pink one. For the examples at the bottom, I'm going to go through and do that. I realize that this is the altitude here that we're working with. If I draw my triangles separately, I've got this triangle that's up here, kind of the left one, side of X, side of 8. And then I have the one that's on the right-hand side, and what I'm going to do to that one is I'm going to turn it so that it's sitting this way, side of X, side of 18. And when I pick those 2 triangles, remember, if you take a look at what we did under case 1, we drew the 2 separate little triangles, left and right. I'm doing that same thing here because I'm using the altitude. So this is kind of giving you a little hint of what it is that you want to do. If it's the altitude that we're talking about, we use the left and right triangles, we draw them separately, and we can set up our proportion. So 8 over x equals x over 18. X squared equals 144. When I square root both sides to solve, I get x equals plus or minus 12, which gives me x equals 12 for my final answer. If I'm dealing with case 2, where we're looking at an altitude, a leg, like we are here, a leg of the big right triangle, so we have a leg here, and we have the whole hypotenuse here. if I'm dealing with one of the legs, I want to make sure that I'm using, when I draw my triangles, the little triangle that contains that leg and the whole big triangle. So I'm going to draw the triangles separately. So the first thing I'm going to do is I'm going to work on the little triangle, and when I draw that, I've got right angle here, x here, hypotenuse of 6 here, and I want to draw my big triangle facing that same direction. So in this case, I'm going to have to take the big triangle, flip it over, and then kind of turn it to get it to sit like this one is. So I'm going to flip it over and turn it, and when I do that, the big triangle with a right angle of this, here's the short leg of 6, and here's the whole hypotenuse, which in this case has part as x and part as 5, so my whole hypotenuse is x plus 5. Once I do that, I can set up a proportion between these sides. So I have 6 over x plus 5 equals x over 6. I'm going to cross multiply to solve. So I get x squared plus 5x equals 36. This is a quadratic equation because of the x squared, so I need to get this equal to 0. I'm going to factor, hopefully correctly this time. Set each of my factors equal to 0. When I look at my two answers of -9 and 4, the -9 over here gets rejected. You need to make sure that you are clearly rejecting an answer if you don't want it, which leaves me with an x value equal to 4. So in these particular questions, one of your options is to draw your two triangles separately. If you're working with the altitude, you draw the two smaller triangles. If you're working with one of the legs, you draw the triangle, the little one that contains that leg, and the whole big triangle. I'm just going to go back here and color code these so that while you're looking at your notes, if you go back, you know exactly which triangles it was that you were referring to. I think the color coding helps, but it's up to you. The notes do continue on the back of this paper, and I am going to go through and do them. The way I taught you how to do this on the front side was to draw the two triangles separately, facing the same direction, so you could set up a proportion with the corresponding sides. On the back of this paper, I'm going to give you little formulas to use to do the same exact process that relieves you from having to go through, flip the triangles around and get them to be drawn so that they're facing the same direction. So you have an option. You can either solve this way, where you draw the triangles, or you can use the formulas that I'm going to be using on the back of this paper. Make sure that you watch video number 2 for day 6.